Okay, this is lesson 4.4, and this is difference of squares. First, before we look at factoring a difference of square, we have to understand what it is. And first, what's a square? Well, a square number is what we're considering here, and it's the result of another number multiplied by itself. For instance, 9 is a square because it's the result of 3 times 3. Some other examples of squares include 1, 4, 9, and 16, and so on. And I came up with these numbers by doing 1 times 1 to get 1, 2 times 2 to get 4, 3 times 3 to get 9, 4 times 4 to get 16, and we could keep going. The opposite of a square is a square root. For example, if we square root 25, we get 5. So being able to identify a square is pretty important. But the key is if you can square root it, it's a square. Now, if you recall the special products from a previous lesson, there was two. There was twins and almost twins. And the important one for this lesson is the almost twins. So for example, if we had x minus 5 and x plus 5, these are almost twins because we have x's at the beginning, 5's at the end, and opposite signs. And the result when we expand almost twins is we just have to do the x times x to get the x squared, the 5 times 5 to get 25, and the sign in the middle will be negative. So the product of two binomials that share identical terms but opposite signs, the result is called a difference of squares. And that's because the first and the last terms of the resulting binomial are both perfect squares. So that means the x squared and the 25 are both perfect squares. So that means we could square root them. So what's important here? Well, the special product, the almost twins, when we expand it, we'll always get something called a difference of squares. So how do you spot a difference of squares if you start with it? Well, it's in the name. Difference means minus. So in between the two terms, there'll always be a minus sign. And if we look at both of these examples, there's a minus sign. And the first term and the last term, we should be able to square root. It's easier to see it with numbers, like 16. If you square root 16, you get 4. No decimals. If you square root 49, you get 7. And if we remember back to the definition of what a square is a number when you multiply by itself, you get, a square is the result of another number multiplied by itself. So x squared, well, that's a square as well. And the reason it's a square is because, well, x squared is just x times itself. If we square root x squared, we get x, because x times x gives us x squared. So x squared is also a square. 4y squared is also a square, because if we square root it, well, the square root of 4 is 2, and the square root of y squared is y, because 2y times 2y, 2 times 2 would give us the 4, and y times y would give us the y squared. So these are both square roots. So that's how you spot a difference of squares. It's got two terms with a minus sign in the middle of the terms, and you can square root both terms. So if you recall, when you expand almost twins, let's scroll down here. When you expand almost twins and you're doing the FOIL, you only have to do the x times x and the 4 times 4. X times x is x squared, and 4 times 4 is 16, and we have a minus sign in the middle. We have a difference of squares. Our goal now is to be able to go from the difference of squares backwards to the almost twins. That's called factoring. So let's see if we can do it. If we want to factor a difference of square, we have to go to almost twins. Well, here's a difference of squares because we got x squared, 49, and a minus sign. So we know we're going to end up with almost twins. So I'm going to make one bracket with a minus, one bracket with a plus. And now to figure out what goes in the brackets, we square root both of those terms. The square root of x squared is x, and the square root of 49 is 7. So what goes in the brackets? X and 7. X and 7. And you could always check by expanding. X times x gives us x squared. 7 times 7 gives us 49 with a minus sign in the middle. So factoring is reversing the process of expanding. So if you see the instruction factor, that means go to the almost twins brackets. Notice the signs of the factors. One will always be plus, and the other will always be minus. So let's try a couple more. I'm going to do 2, and I'm going to leave 2 for you. So I'm going to do the first 2. Look at this note. It says sometimes factor out a GCF first. Well, the last lesson was about greatest common factoring. The first thing we need to do whenever we see the instruction factor is look for a greatest common factor. So if we look at the numbers 9 and 64, is there a number that's common between 9 and 64? And we could try and look at all the factors, but I'm going to tell you there is nothing common to 9 and 64 other than 1. So now we ask ourselves, is this a difference of squares? Well, there's a minus sign in the middle. Can we square root both 64 and 9x squared? Well, let's try. I'm just going to do the work up here. I'm going to get a calculator for this one. Can we square root 64? Well, we look for the square root button, 64. We get 8, so we can square root 64. Can we square root 9x squared? Well, we know the square root of x squared is just x. What's the square root of 9? Square root of 9 is 3. So the square root of 9x squared is just 3x. So we can square root both of those terms. So if we want to factor it, we can make almost twins. 1 minus, 1 plus. And what goes in both brackets? The 3x goes first. And the 8 goes second. And if we wanted to check, we could just expand it, and we'd end up right back here. One more example, and then 2 for you to try. 9x squared minus 36. Well, let's look for a GCF first. In this example, there is a greatest common factor. 9 divides into both 9x squared and 36. So we're going to start by dividing both of these by 9. 9 divided by 9 is 1, so we just have x squared. And negative 36 divided by 9 is negative 4. So 9 first, and then x squared minus 4. And now we ask ourselves what we're left with, is that a difference of squares? And the answer is it is. Because x squared, if we square root it, we get x. 4, if we square root it, we get 2. So we keep our greatest common factor in front. And now we write our almost twins. 1 plus, 1 minus. It doesn't matter which one's first. Square root of x squared is x, so x goes first in both brackets. And the square root of 4 is 2, so 2 goes second in both brackets. All right, that's it for the lesson. Try these 2. No greatest common factor for the first one, but there is a greatest common factor for the second one. So try both types, and then check your answers on the course website, and try some practice questions. That's it for lesson 4.4, and I'll see you in our last lesson of Unit 4, 4.5, where we looked at factoring trinomials.